Hello, students. This is Marquis Learning Center's tutoring class, and this is our contact number. And we are majorly tutoring all high school maths, calculus, advanced function, and we offer the first free online class. Please contact us. And today, I'm going to explain to you how to do a calculus question. So this is an grade 12 calculus question. The question is asking about a cylinder is inscribed inside a speed with a radius equal 10 units. Find the maximum of the radius and the height for the cylinder. So this is the two variable is asking for a maximum. So the diagram is like that. The cylinder inside the speed. So the line here from the center to the corner is the radius. The radius of the circle is 10 units. So to make the vision easier, so I draw it into a 2D shape. So the rectangle will become a cylinder. So we draw the radius here is 10 units. And we are looking for the radius for the cylinder from here to here. So we put it for R, radius for cylinder. So how about the height? So if you look at these cylinders face as a rectangle, so the center is here, and that's the height of the rectangle. So the height from here to here, just take half. And then we put it for H over R. So for this kind of derivative question, we're going to always take one constraint equation and one optimization equation. The constraint equation is applied the known unit to write the equation. So we are going to apply the Pythagorean theorem. C squared equals A squared at B squared. So this is a right triangle. So we are going to take the hypotenuse is a 10 square equal radius square at H over R square. So we are going to isolate the radius square. So radius square is equal 100 minus H square over 4. So now we are going to apply this radius into here. So we're going to find the volume of the cylinder is equal pi r exponent to h. So pi is a constant. R squared is equal 100 minus hr exponent 2 over 4. So we're going to substitution put here. And we're going to do the first derivative. Let's write it on the second page. Now we're going to write the derivative equation. Now we're going to substitution r squared here. So we're going to write V volume for C is equal pi times 100 minus h squared over 4 and times the h. So we successfully change this equation into one pi and h times together. And then we do distribution, become 100 pi as pi h minus 4 become 1 over 4. So pi and h times h exponent 2, we get h exponent 3. Now we are going to do the problem 1. So the first one is going to be equal 100 pi. So the second one is going to be 1 over 4 times 3 pi h exponent 2. So now we simplify. The problem 1 is equal 100 pi and minus 3 over 4 pi h exponent 2. Now to find the height, so we are going to do set the equation equals 0. And in the problem 1, we are going to find h. So we're going to move this into the other side. So it will be 3/4. So times pi, h exponent 2 equal 100 pi. Now to solve x, we're going to put h exponent 2 equal 100 pi. It's going to be divide 3 pi over 4. 3/4 pi, excuse me. And from here, we cancel pi. And then we have a 100 divide 3/4. So I'm going to move a space here. So I'm going to put h is equal 100 over 3 divided by 4. And we're going to solve this exponent 2 with bracket and put exponent 1/2. So now pi equal how much? We are going to use a calculator. So to square root 100 divide 0.75. Now to solve this square root, so we're going to find h is equal 11.58 unit. Now we find the h, we're going to find the radius. So the radius, we're going to substitution into the constraint equation, radius square. So we're going to put radius square. So it's equal 100 minus h square over 4. Now we do substitution. H equal 11.58. So radius square equal 100 minus 11.58 exponent 2/4. And radius is equal. So we are going to use a calculator to find. It's equal 100 subtract 33.33. We solve this square will be exponent 1/2. And then from here, we're going to get radius is equal 8.16 unit. So to maximize the volume of the cylinder, so we find the height. So h equal 11.58 and the radius is equal 8.16. And that's how we solve the calculus equation from the constraint equation and the optimization equation, and use the substitution to the optimization equation and simplify and get the derivative equation ready in a problem 1. So you're going to find the only unknown, the variable is h. So plug in h into the constraint equation, you find radius. And then you solve for all. As for the h and the r, the key thing is use the available information, write the constraint equation, and write the optimization equation and substitution to get the first derivative equation ready for the only one variable, and solve the variable and use the variable, come back to the constraint equation, solve the other unknown. So once you understand the concept, it's quite simple, and that's how to do it. So, and we solve the equation, and then, and this is our class. for Smart Kids Learning Center. This is our contact number. And yeah, please subscribe. And then I'm going to continue to make videos to simplify way to explain calculus and advanced function. And see you in next video. Thank you. Bye.